Good morning, boys and girls of the North Campus. My name is Mohammed, and you're listening to Channel 203, The Leaders in Logic. Today's topic will be proving logical equivalence by identifying the set of true and false assignments. Feeling scared? It's only natural, but that's why we are here. Our outstanding staff will cure all your logical problems. But before we begin, let's review what logical equivalence really is. Logical equivalence is simply the statement where P, if and only if Q is a tautology, or where P, if and only if Q is always true. So this means when P is true, Q is also true, and when P is false, Q is also false, and vice versa. Let me say that again. P and Q have exactly the same values for exactly the same inputs. If you're feeling a bit under weather from all this, our superb weatherman Alex will have you feeling better in no time.
Thanks, Mohammed. Now time for weather. This weekend, it's gonna be raining. Darn. Which also means that it might be a little cloudy. Now, being a TV weatherman, I'm a little hit or miss with the weather. So, if it's not cloudy, then it's not gonna rain. So, I think that we can use logical proofs and inference in order to prove to you that this is correct. So first of all, let's set each of these statements to a variable. We'll say that it is raining is gonna be equal to P. And now let's go over here and we're going to say it is cloudy. It's going to set that to Q. So I said, if it rains, then it will be cloudy. I also said, if it is not cloudy, then it is not going to rain. So now we can use logical inference to prove that both of these statements mean the exact same thing. So, in a P then Q statement, we know that the only time that it can be false is when P is true and then Q is false. So now let's take those values, P being true and Q being false, let's put them over here. So now we have Q is false, so not false, then P is true, not true. So that's true, then false, which is false. And once again, on the other side, if it is raining, then it will be cloudy. It is also false. So because both of these are false, we can say that these statements are logically equivalent. So now at this point, some of you in the audience might be questioning, well, are we absolutely sure that this always works, that these two statements are logically equivalent? So why don't we mosey on over to the truth table? So now you can see the truth table. These are all of the different cases that can happen for if P then Q and not Q then not P. So now you can see that both of these have identical values, which once again proves that they're logically equivalent. And actually, a quick little nifty tidbit for the rest of you, we actually just did a proof by contradiction. That is how we were able to prove that both of these statements were the same. We proved one to be false, and then when we tried to prove the other one true, it ended up being false. That means that these statements are logically equivalent. Well, that's all for weather. Now on to Colin with sports.
Thanks, Alex, and hello to all our viewers out there. Today, we are going to use the world of professional football to help explain how to prove logical equivalencies. Let's suppose that P, Q, and R are propositional variables. P equals the Patriots win the Super Bowl. Q is Tom Brady wins Super Bowl MVP. And R is Eli Manning wins Super Bowl MVP. We are going to look at the statement P and Q or R, meaning that either the Patriots win the Super Bowl and Tom Brady wins the Super Bowl, or Eli Manning wins Super Bowl MVP. We're going to compare the statement to P or R and Q or R, meaning that either the Patriots win the Super Bowl or Eli Manning wins the Super Bowl MVP, and Tom Brady wins Super Bowl MVP or Eli Manning wins Super Bowl MVP. If we take a look at the statement on the left, we can see that the statement is true if R is true, because if R is true, then the overall OR statement evaluates to true. On the other hand, if R is false, then for the OR statement to evaluate to true, both P and Q must be true. In any other case, the statement will evaluate to false. If we look at the statement on the right, we can see that if R is true, then both P or R will be true, and Q or R will be true, meaning that the overall AND statement will also be true. Again, if R is false, then both P and Q must be true to make the overall statement true. If neither of these situations is true, then the statement will evaluate to false. Notice that these statements are true in the same exact situations and false in the same exact situations. This means that the two statements are logically equivalent. Now, if you're asking me, Michigan grad Tom Brady will win Super Bowl MVP and his New England Patriots will win the Super Bowl. But as you can see, it's not that simple. For sports, I'm Colin Peterson. Back to you, Mohammed.
So, ladies and gents, that is how you prove logical equivalence by identifying the set of true and false assignments. I hope your logical thirst has been quenched for the day. From all of us here in Channel 203, I'm Mohammed. You stay classy, Ann Arbor.